Welcome back to our Algebra 1 series. Today we are up to section 8.6 where we will be looking at complex rational expressions. A complex rational expression has a rational expression in its numerator or denominator or both. So something like this. You might be thinking to yourself,
No! God, please, no! No!
but don't worry, we actually have a couple of ways of dealing with these kinds of problems. Here's the first way. We can simplify a complex expression by multiplying the numerator and denominator by an expression equal to 1. So we can multiply this expression by n over n, which is equal to 1. In this case, n is the least common multiple of all of the denominators in the original expression. So here we have three denominators, 4, 2, and 8. So what is the least common multiple of 2, 4, and 8? What is the smallest number that 2, 4, and 8 would go into evenly? In this case, it would be 8. We could use something like 16 or 32, but 8 is the smallest number. It is the least common multiple of 2, 4, and 8. So now, just multiply across and distribute when needed. Let's look at just the top half of this equation first. We're going to distribute 8 to 3 over 4 and x over 2. So we end up with 3 over 4 times 8 plus x over 2 times 8. And on the bottom, we just get x over 8 times 8. Let's scooch this over so we have a little bit more room. Again, looking at the top first, 8 times 3 over 4 gives us 24 over 4, and 8 times x over 2 gives us 8x over 2. Looking at the bottom, this becomes 8x over 8. Again, looking at the top first, this simplifies to 6 plus 4x. The bottom simplifies to just x. If we wanted to, we could factor out a 2 out of the numerator to get 2 times the quantity 3 plus 2x all over x. What about something like this? Well, it's not that bad. In this case, we actually have a different way of solving this kind of problem. Let's focus on the center bar and see that we are dividing one fraction by another. Since we're dividing one thing by another, we can multiply instead if we use a reciprocal. So here, we can take the reciprocal of the denominator, 2 over x minus y. Its reciprocal would be x minus y over 2, and we can multiply these two fractions instead of dividing them. So we can multiply across. The top becomes 4 times the quantity x minus y, and the bottom becomes x squared minus y squared times 2. We'll do another scooch to make some room. And we're going to factor everything. So looking at the top first, the 4 just factors into 2 times 2. On the bottom, we have a difference of squares. We have x squared minus y squared. Remember, this factors into x minus y times x plus y. So we have a 2 on the top and a 2 on the bottom that cancel. We have an x minus y on the top and bottom that both cancel. And this simplifies down to 2 over x plus y. Let's jump over to the whiteboard and do some fun examples. Let's start with something fairly straightforward. 3 plus 5 halves all over 5 fourths. So there's two ways we could take a look at this. We could find a least common multiple of denominators, or try to multiply by a reciprocal. In this case, let's look at the denominators first. And it might be easier to think of this 3 as 3 over 1. So we've got 3 denominators, 1, 2, and 4, and the least common multiple of those denominators is 4. So we're going to take this whole fraction, and we're going to multiply it by 4 over 4. This is 1. We're allowed to take a thing and multiply it by 1. So let's look at the top first. We're going to make a little nice equal sign here and do this. And we've got 3 plus 5 halves. So we have this quantity. And we could think about it like this if we wanted to, that we need to distribute this 4 into. So 3 times 4 is 12, and we have 5/2 times 4. So it's going to be 20 over 2. And I'm going to write it out. I'm not going to simplify it right away. We have 20 over 2. Down here, we've got 5 over 4 times 4. So it's going to be 20 over 4. 20 over 4. And if it helps, you can make this main, fraction bar a little fatter, or use a different color. So you can look at the top first and look at the bottom second if you want to kind of divide these two. So you can see by multiplying by the least common multiple cancels things out, gives us nice happy fractions that simplify. So let's take a look at this. We have 12 plus 20 over 2. Well, that's 10. And here's our bar. And 20 over 4 is 5. So we have 22 over 5. That's kind of a weird answer, but that is the answer. And these problems take up a lot of space, so we're going to have to clean this off to do our next example. Alright, we're going to try to squeeze this in as friendly as possible. We have 3 over x all over, stay on the screen please, 1 over x minus 1 over 3x. Okay, dividing or multiplying by reciprocal, it would be 1 over this entire mess. So we can't do that one. But we have 3 total fractions in this. We have 3 denominators. So what is the least common multiple of these 3 denominators? It would be 3x, because 3x goes into 3x, x goes into x, or x goes into 3x. So we're going to do the same thing. We just have a variable this time. So we're going to multiply this whole thing by 3x over 3x. We can take this whole blob multiplied by 1, and we haven't broken any rules or anything. So we're going to multiply across and distribute, and I am going to maybe skip a step or two, but say we'll have 3 over x times 3x. So I'm going to combine that to be 9x over x, and we'll make our fat bar again. And we have 1 over x times 3x. We're distributing this 3x across, and again, you can think about it like this. Whoops. There's a parentheses there, I promise. It's big and fat. Okay. So 3x over x, I will write this one out. 3x over x minus 3x over 3x. That's going to cancel itself out pretty easily. So 9x over x. Well, that is 9. And fat bar. 3x over x is 3. And 3x over 3x is 1. We'll end up with 9 over 2. And we are once again cleaning this off to make room for the next problem. Okay, let's get up here in the corner as best we can. Let's say 2 over a plus b. And this whole thing is over, we'll make a fat bar here, 4 over a squared minus b squared. So now we have a case where if we want to, we can find the reciprocal of this entire lower denominator and just multiply across. So let's do that. I'm going to put it up here. I'm going to multiply by this reciprocal of this thing. So we just flip it upside down, put the 4 on the bottom, the a squared minus b squared on top, and erase all of this. Okay, so now we just multiply it across. So I'm just going to kind of rewrite it up here. 2 times a squared minus b squared all over. And just to keep it neat, I'm going to put the number in front of the other stuff. 4 times a plus b. I'm going to jump down here because we need all kinds of room and put a nice happy bar. And I'm going to just do one expansion here. I'm going to rewrite the 2. And we have a difference of squares, just like we saw in the slides. So this is a plus b times a minus b. We have a squared minus b squared, a difference of squares. it factors into this. And then we'll just rewrite the bottom, 4 times a plus b. So now we've got stuff that cancels. So this a plus b and this a plus b, it's over itself, so these will turn into a 1. The 2 over the 4 turns into a 2. So we're left with a minus b over 2. And there we go. All right, we're going to clean this off, and we're going to do a bit of a doozy here. Okay, I'm not sure how well this is going to fit, but we are going to do our absolute best. I'm going to try to write small, and hopefully it still shows up. We have g over 2f plus g plus 2 over f plus 1. All over. So we're going to put a mega fat bar, all over. Oh, fill in the bar, fill in the bar. All over g squared over f plus 1 plus 2g plus 3 over f. Oh boy. So multiplying by reciprocal won't work because the reciprocal would be of this entire mess. It would be 1 over all of this, and that seems terrible. So we need to find the least common multiple of all the denominators. So we have 4 denominators, 2f, f plus 1, another f plus 1, and f. So the least common multiple will be the smallest thing that these 4 denominators will all go into. We need to find 3 because 2 of them are the same. So that would be something along, let's, where do you want to put this? Squeeze it down here maybe? I'm going to say the least common multiple is going to be 2 times f times f plus 1. So whatever this ends up being, f can go into it because it's right there, 2 can go into it because it's right there, and f plus 1 can go into it because it's right there. So I'm going to simplify this as just 2f times f plus 1. Now we could distribute and have f squareds and stuff, but let's just leave it in these pieces for the time being. So this is an f, I promise. 2f times f plus 1. So we're going to multiply this gigantic fraction by 2f f plus 1 over 2f f plus 1. Oh boy. So we're going to distribute this monstrosity to this and this, and then the same thing to the bottom 2 fractions. Let's just look at the top first. So if I have this, we have 2f times f plus 1 times this fraction. So let's see if I have room for this. We're going to have 2f f plus 1 times g over this, 2f. So you see how things start to cancel when we start, using these least common multiples. Oh boy, this is going to get tight. Plus 2f f plus 1 times g plus 2. Boy, this is something, isn't it? Over f plus 1. There's an f plus 1 in there. So we can see what's going to cancel. This 2f and this 2f are going to cancel. This f plus 1 and this f plus 1 are going to cancel. Well, let's not get ahead of ourselves too quickly here. We're going to put the big fat bar here. Fill in the bar, fill in the bar, fill in the bar, fill in the bar. So now you have to take this thing, 2f times f plus 1 times this numerator, g squared, over f plus 1. Again, we're going to have a cancellation of f plus 1s, plus the same thing, 2f times f plus 1 times 2g plus 3. Is that on the screen? Oh, just barely. 2g plus 3 all over f. Oh my goodness. So now that we've found this, I'm going to erase this really quick. And let's look at this mess and see what cancels. Okay, so this and this are going to cancel. F plus 1 and f plus 1 are going to cancel. F plus 1 and f plus 1 are going to cancel. And we have 2f and f. So this f and this f are going to cancel. Well, look at that. We managed to wipe out all of the denominators. So let's just start adding and distributing. We're going to focus on the top here. So we have f plus 1 times g. So I'm going to expand that. I'm going to say that that is, I'm going to get as much room as possible. We're going to distribute. So that's fg plus g plus, we're going to distribute this 2f to the g plus 2. That's 2fg plus 2f times 2. 4f. That's now this top, and all of this went away. I'm going to rewrite our fat bar here. Fat bar, sort of. We have 2f times g squared. I'm just going to write that out. 2f g squared plus this. 2 times f plus 1 g blah, blah, blah. So we're going to have to FOIL this one here. So we're going to have 2 times 2fg. I'm going to do it like this. 2fg, that's the first. Now the outer, that's 3f plus 3f. The inners, that's a 2g. 2g, and then a 3. Oh my goodness, what a mess. And I'm going to distribute this 2 across all of this. I'm just going to squeeze it in down here maybe. This is a lot of math for one whiteboard, isn't it? So this is going to be 4fg, and this is going to be 6f. Again, I'm just taking this 2 and distributing it across this mess. This is going to be 4g plus 6. Ooh. Equals. So now we have some like terms up here we can combine. We have an fg and 2fg. So that's 3fg plus a g plus 4f all over this mess. Let's take a look here. We have fg's, an f, a g, a 6, and an fg squared. So we can't combine any of those terms. So it's 2fg squared plus this thing that we distributed, 4fg plus 6f plus 4g plus 6. Dear Lord. Alright, let's clean off this disaster of a math problem and do our bonus problem, then call it a day. Okay, we're going to start up here. We're going to say a over b plus c over d. And you know it's going to get more complicated than that, so we're going to add our super fat bar here. All over b over a plus d over c. So we can't do a reciprocal because it would be 1 over this. We need to find the reciprocal of the entire denominator down here. So now we're doing that least common multiple thing again. So we have 4 denominators, a, b, c, and d. So the least common multiple of those 4 things is a, b, c, d. So we need to multiply this whole fraction by a, b, c, d over a, b, c, d. So it's the same thing over itself, so we're just multiplying by 1. Now we need to distribute this mess to these 2 entities and the same mess to these 2 entities. Let's see how much space that takes up. So let's see here. We're going to have a, b, c, d, and I'll do this, times a over b plus a, b, c, d times c. Again, I'm just taking this, taking this entity and multiplying it and distributing it. So that's why we have this here times a over b, and then we're going to have the c over d, and then we need our megabar. Fill it in. And then we're going to have this a, b, c, d times b over a plus a, b, c, d times d over c. So let's take a look at what cancels here. We've got all these multiplied together, divided by a b. So this b and this b are going to cancel. Let's treat them as like ones. This d and this d are going to cancel. This A and this A will cancel. And this C and this C will cancel. So you can see again, using this least common multiple, even though it's weird and complicated and looks messy, ends up wiping out the denominators of all of these fractions within the fraction. So now let's just simplify. We'll try to squeeze it in down here. Let's see how well that worked last time. A times C times D times A. That is A squared CD. Right? A squared CD plus A, B, C, and another C. A, B, C squared. All over, again, this is the fat bar, whoops, B, C, D times B, so that would be B squared C, D plus A times B times D times D. A, B, D, that's a B, squared. And that's it. We can't simplify this expression any further. And that's it for today. This is actually the last video in our Algebra 1 series. Hopefully some of these videos have been helpful to you. If you're interested, we have a geometry series that's ongoing, and an Algebra 2 series that will be starting up very soon. Thanks for watching. We'll see you next time.